Hello, I'm going to be going over a new design for a laptop cooling system that uses heat sinks that I'm going to be simulating in Comsol for my current laptop. A few years back, I ended up purchasing a new laptop. It is a Microsoft Surface Laptop 5. And I did this for a few reasons because it's a much slimmer design. So that means it'll be much lighter in my backpack. It had upgraded CPU. It had a upgraded RAM compared to my old one, which is much nicer to work with SolidWorks with because my old one I was only working off of 8 gigs, while my current one has 32. The drawback, though, of it being a much thinner design is that it is very prone to overheating, unless I have some form of extreme air movement around it. So if I am charging my laptop, it has a tendency to overheat. If I'm running rather large simulations, it has a tendency to overheat. So I try not to run ANSYS on here as much. SolidWorks runs better, but when I'm trying to do a larger assembly, it has a tendency to overheat. And with this being my school laptop, I would prefer that those programs don't overheat my laptop as much. So I'm gonna try to help cool down my laptop with the use of this new laptop cooling system. There are current models that exist like the one shown here. One of the downside to these ones is if you go for the cheaper designs, then you're going to be looking at um, more noise that's produced and then more dust that can possibly be blown into there because they don't really have filters that stop the dust from getting into there. Well, this one is a bit more expensive. I want to say about $80. Though it is much quieter and it does have a cleanable filter on there. While if you go for the smaller ones, they just don't have the filter at all. So this new design, I want to completely get rid of any chance of the dust getting blown into the computer. But first, I need to validate that the design will work before I even try to attempt a physical model. To run these simulations, I am going to be using Comsol Multiphysics version 6.1. I'm going to be doing this with a few assumptions of the system. I am assuming conduction heat transfer between the chip and the laptop shell, and I'm going to be giving it a little bit more room to play using thermal grease. I'm using a air temperature of about 70 degrees Fahrenheit, which is about the normal temperature within buildings in the United States. I'm also going to assume that the thickness of my laptop shell is about 1/16 of an inch. I couldn't find a direct measurement for this, so I figured that would be an appropriate shell thickness for how light and thin my laptop shell feels. And I'm going to be assuming that the laptop shell is made of aluminum and that there is no internal cooling within the laptop for this simulation, because if I went more into this, the um, simulation would be much more computationally expensive, along with the fact that I am not entirely certain what type of cooling system that my laptop is using other than just air cooled. So from doing an online search, I found a few specs of my CPU that is within my laptop that I found on Intel's website, and I ended up finding that the heat dissipation is about 15 watts, and that's at like the maximum that it'll run at. And I also found some basic dimensions of the chip itself. Then also for the fan for this system, I am going to be using a company that is known to have really quiet fans when they're running, and I ended up finding the average wind speed from this from using the airflow of 9.4 meters cubed per hour that I found on their website for the specific fan that I picked out, and I found the average wind speed using the area of my system that the air is going to be flowing through. I'm also going to be using for this system a design that We'll have natural convection instead of forced convection, so I can see if the fans are actually needed. This is the design that I'm using within Comsol. You can see down at the bottom of this, there is a thin plate, and that is the shell of my laptop. Above that is about an eighth of an inch thick piece of copper that I got from McMaster-Carr. Above that is a simplified version of the fins that I also found on McMaster-Carr, and that box around there is the wind tunnel that'll be used for the forced convection. This is the results from just natural convection. The maximum temperature reached is 92.4 degrees Celsius. The minimum is 75.2 degrees Celsius. While for the chip, it is a maximum of 92.4 degrees Celsius, which is expected because that would be the hottest part, and that is the chip, and a minimum of 77 degrees Celsius. And this is the results from forced convection or with the fans applied. The whole system, the max temperature dropped down to 48.1 degrees Celsius, while the minimum dropped down to 24.8 degrees Celsius. And the chip, again, staying the same as the max temp of the whole system, is 48.1 degrees Celsius, while the minimum is 28.6 degrees Celsius. So after running the simulations, it seems like there is a total of 64.3 degrees Celsius of difference when it is from the natural to the forced convection, where the minimum temp difference for those two scenarios is about a 50 degrees Celsius difference. This is a large jump in temperature difference, but it is expected for of having forced convection rather than having the natural convection, because it's a much more efficient process of cooling down systems while using forced convection rather than just having still aired cooled natural convection. I do believe that the simulations that I've done does show that a homemade design can be plausible, and some real world testing will be done to check that, and that's going to be on the next slide. While this design does have plenty of assumptions, it does have it's an idealized case for the most heat transfer from the CPU to the shell, to the copper, to the fins. Obviously, the CPU is not going to be directly touching the shell of my laptop, so there's going to be some helpfulness from the computer on that side, so it's not going to be as hot when it gets to the copper plate, because there is an internal cooling system within my computer, though it's not working super well, and that's why I had to make this project. Um, though also, I do believe that the simulation is correct, because for the natural convection, it said that the CPU is about 100 degrees Celsius for that version of the simulation, and the maximum temperature of the CPU, while it's got a 15-watt dissipation for it, will be around 100 degrees C from the specs that I found online for my CPU. For the future of this project, I want to get a design finalized, uh, following closely to the parameters that I have set for the Comsol simulation. And from there, I'm going to be using a Arduino Nano that is already within my possession to help check the temperature at different levels. And I'm going to find components that I from various websites to help me keep an eye on the temperature using the Arduino. And then also in the future, I want to turn this into a way for when the temperature gets to a certain level, it'll turn on the fans to bring the temperature back down. And when the temperature gets to another level, it'll turn off the fans. And this is just a simple design that I have up right now. It doesn't have the fans in there yet, and it still doesn't have a spot for the Arduino and stuff, but this is the first steps into the real world design.